We have to find the equivalent resistance of a circuit containing 5 resistances using Wheatstone bridge principle. So this is the fourth resistance and fifth resistance. So this is the circuit diagram containing 5 resistances, and these 5 resistances are connected between A and C, between the 2 points A and C, A and B. Resistance R1, R2, R3, R4, R5. This one is C and D. That means these 5 resistances are connected between the 2 points A and B, and modified circuit diagram will be as follows. In this case, we can draw the modified circuit diagram containing the same 5 resistances, and these 5 resistances will form Wheatstone bridge between the 2 points A and B, between the 2 points A and B. Point A and B, between them R1, R2, R3, R4, R5 are connected. This point is D and the lower point is C. In this case, in the diagram, in the circuit diagram, the 2 points D and C will be pulled or stretched, and this resistance is R3 between the 2 points D and C, and this is R1 between the 2 points A and C, and between the points C and B we have the fourth resistance R4. The point D is moved upwards and the point C is moved downwards. Means D and C are stretched upwards and downwards respectively, and we get this simplified circuit diagram. And according to Wheatstone bridge principle, if R2 by R5 equal R1 by R4, that is the ratio of resistances above the middle resistance R3 will be equal to the ratio of resistances below the middle resistance R3. That means R2 by R5 is the ratio of resistances above R3. So if R2 by R5 equal R1 by R4, then the resistance R3 can be neglected or removed from this circuit diagram, because no current flows through the branch containing the resistance R3. Now we can draw another modified circuit diagram. Here R3 can be removed from this circuit diagram. This is R2, then R5, and in the lower branch we have R1, R4, then connected to the point B. The point is A and this point is B. This is R2 and R5, and the lower branch we have the resistances R1 and R3, R1 and R4, but R3 is removed from this circuit diagram. Therefore, the equivalent therefore the equivalent resistance the equivalent resistance between the 2 points A and B, between the 2 points A and B is given by RAB equal R2 plus R5 R2 and R5 are connected in series combination. That's why R2 plus R5 into R1 plus R4. R1 and R4 are also connected in series combination. Divided by R2 plus R5, bracket closed, plus R1 plus R4, bracket closed. Here the equivalent resistance of R2 and R4, R5 and R1 and R4 are connected in parallel combination. So we get the equivalent resistance between A and B. R2 and R5 are connected in series combination. So that's why we get the equivalent resistance of R2 and R5 as R2 plus R5. Similarly, R1 and R4 are connected in series combination. That's why equivalent resistance of R1 and R4 is R1 plus R4. But